Alright, so today we are going to start on 1.4. This is combination of functions. So that's where we'll have two functions, and we're going to do a lot of different things. We're going to do arithmetic expressions. That just means add, subtract, multiply. Not so much dividing yet. The main ones we're going to do is like compositions. That's where you're plugging functions into functions. And the big thing with that is figuring out what the domain will be when we're doing that, okay? So some of this you're going to be like, that's easy. And some of it's like, oh, that's new. It's a little challenging, but you guys will be good. Okay, so let's start with this one. F of x is this. It's a quadratic trinomial. Now what we need to figure out is what is f of 2x and simplify. What is 2 times f of x? What's the difference between those things? And then later we'll plug in this versus that versus that. And we're going to try to simplify these. And they look very similar, but there's some subtle differences. For example here, this is f of x, this is f of 2x. What this means is that everywhere I see an x, what am I going to put instead? A 2x. So there's still a variable, so I won't be able to just simplify this to nothing, or to a constant, but we will simplify as much as we can. So here, I have a negative, and then where I see the x, I'm putting 2x. Then I square it. Make sure you're careful with your parentheses so that you don't forget something like squaring both of them. I'm going to do 3 times 2x plus 4. Alright, let's simplify that. 2 squared is 4, and then I'm going to times it by negative, so this is negative 4. Remember to also square the x. 3 times 2x is 6x, and then we just have a 4 hanging out. And there we go. That's f of 2x. Does that make sense how you just plugged in a 2x instead of an x? Okay, now how is that different than 2f of x? How is that one going to be different? Go ahead, Calvin. Yeah, we just take f of x and we double it, okay? So I'm going to take 2 and distribute it to the negative x squared plus 3x plus 4. And when I distribute that, I'm going to get negative 2x squared plus 6x plus 8. Pretty simple stuff, right? You're just doubling. Alright, so you're getting kind of the idea here. Let's get some help from you guys. Is this a rep class? Nope. Let's just go to Andrew. Andrew, how is f of x plus 2? What are we asking? What are we doing right here? Awesome, let's try that. So we have a negative, and then instead of an x, we're going to put in x plus 2 squared. Then we have 3x, but instead of an x, we're doing x plus 2. Then we have 4. Okay, now when you see this right here, what is a common thing that students do that's wrong? There you go. They'll say, oh, that's x squared plus 4. But that's wrong, right? Let's write up here. When I do x plus 2 squared, I need to multiply it by itself. When I distribute it, I need to make sure that x gets distributed everything that 2 does as well. That's x squared plus 2x plus 2x plus 4. And if I combine those middle terms, that's x squared plus 4x plus 4. So, bring that over here. X squared plus 4x plus 4. I have to distribute that negative still, but make sure you're squaring it correct. Then I'll distribute the 3 here. That's 3x plus 6 plus 4. Alright, I'm going to distribute that negative. We'll combine like terms, and then we should be good. So that's negative x squared plus, or minus 4x, because we're doing a negative there. are some like terms I could combine here? Good, and that will just become negative x. And if we do negative 4 and 10, I believe that gives us 6. All right. That was a little more work, but you understand how to do it. Awesome. Okay. Let's go to Carson Murdoch. F of x plus 2, what is that asking us to do? Are we plugging anything in? Just add in 2, right? So that one's going to be my favorite one. When we do f of x plus 2, all we're doing is we're adding 2 to it. Oh, that's plus 2. So I'll still have the negative x squared plus 3x, but then what is our constant term going to be? 4 plus 2 is 6. Alright, I like that one. That's pretty easy, right? Okay, last one, f of x plus f of 2. What is that asking you to do? F of x, we know what that is. We're going to add it with f of 2. What is f of 2 asking you to do? So let's figure out what f of 2 is first. And the way I'm doing this, I'm sorry, I can't really scroll down, so I don't have a whole lot of space. So I'm sorry, our technology isn't working. Well, let's figure out what f of 2 is first. Have we done that already? We haven't. So we have negative 2 squared plus 3 times 2 plus 4. So 2 squared is 4, but there's a negative. The negative 4 and the positive 4 cancel out, so f of 2 is just 6. So I'm going to come down here. Hopefully you can see this. I'm sorry if you can't. F of x plus f of 2. F of x is negative x squared plus 3x plus 4. And we just said, oh, sorry, this would be f of 2, right? F of 2 is 6. So that will just be negative x squared plus 3x plus 10. And there you go. All right, any questions on this, guys? Kind of just different ways you could do it. Hopefully you're feeling okay. Let's keep on rolling. Okay, this page just shows some of the different ways you could see operations asked. For example, if it says f plus g of x like that, it means you're taking f of x and you're adding it with g of x. Okay, it's just a different way you can see it. Same with f minus g of x is just you're subtracting them. What does that little dot here mean? You're multiplying them, and then of course right there you're dividing. You've done that before in a lot of other math classes, so we're not going to spend a whole lot of time on that. Instead, we're going to try to get ahead to the ones that you haven't seen before. But we'll do some practice too. All right, so let's do this one. I've got f of x is 6x squared minus 2x, and g of x is 3 minus 1 over x. All right, so let's look at this. What is this telling us to do? F plus g of negative 1. First off, what are we plugging in for x? Negative 1. And then what are we doing with the two functions f and g? Good job. So why don't we start by figuring out, okay, what is f of negative 1? And also what is g of negative 1? And then we're just going to add those together, okay? All right, f of negative 1, we're going to do 6 times negative 1 squared minus 2 times negative 1. Negative 1 squared is 1, so we get 6. And then negative 2 times negative 1 is 2. So 6 plus 2, this will give us 8. All right, let's have Alexis help me out with g of negative 1. How would I write that out?
Wait, so we're plugging negative 1.
function for x, yes. So we start with this 3 minus, we'll do 1 over, but instead of x, what are we putting in? Yeah, there you go. So we're doing 3 minus, and this will become negative 1. What is 3 minus negative 1? That'd be 3 plus 1, which is 4. So now it wants me to do f plus g of negative 1. That just means f of negative 1 plus g of negative 1. What is 8 plus 4? There you go. That's how you do something like that. Alright, so then let's look at number 2. We've got f dot g of 2. So Juliana, what is this asking us to do? If we see that little dot there. On this one right here, I'm not sure we get. Oh, okay. So this is a different problem. Sorry. Now we're going over to this one right here. I'm just asking, what does that dot mean? We're multiplying after we plug in 2. All right. So let's do that. Let's do f of 2, g of 2. I'm going to give you guys a quick head start, see if we can get the same thing. But plug in 2 to f, plug in 2 to g, and then you'll multiply those together. Give you 30 seconds. All right, let's go over this. When I did f of 2, I got 20. Do you guys agree with that? I do make mistakes, so check my work. Some of you were like, oh, I got something different. Well, maybe you're right. But you guys, do we agree with 20? What about 2? I got 5 halves, or in other words, 2.5. Is that what you guys got? So when I times those together, 20 times 5 halves, that's 100 halves, which is 50. You guys able to do that on your own? Feeling okay? Okay, well then let's keep on rolling. We only got a little bit left in class, so let's go through as much as we can. Okay, so now we're given f of x and g of x. They're the same thing. But now it's asking us to simplify g of f of x. Are we plugging anything in on this one? No, we're just going to take these two functions and we're going to subtract them. But then it's going to ask us to figure out the domain. So before we do that, what is our rules for domain? There's two rules. What are they? Go ahead. So that, I think that's more like anything a function, like for every x it can't be a y. Okay, so that would be a function. Sorry, okay, so yes, you're right. So if I'm looking at a graph, vertical line test, we can't have any repeats. But with these, I don't really know what these look like. I think that's a quadratic. This one's kind of ugly. What if we're just looking at the equation? There's two things we got to make sure we don't do. Think the microwave. Go, Jersey.
We got a zero in the denominator.
Great. No zeros in the denominator and no square negatives and square roots. Are we going to have any square roots here? But we do we have a denominator, so we'll have to be careful with that. Okay, so I'm going to zoom down here so we can have a little more space here. Okay, so let's subtract these. If I do 6x squared, and we gotta be careful in the way that we write this, because we have to distribute the negative. We're doing g minus f, so we gotta do g first. G is 3 minus 1 over x. And now with f, we've got to make sure we write it in parentheses. Why am I putting parentheses here, guys? Distribute that negative, so this is 3 minus 1 over x minus 6x squared minus 2x. Oh, I was testing you guys, see if you're paying attention. Good job. Okay. Now, do we have any like terms? Can we combine anything there? Nope. So, maybe I'll just rewrite this so it's in standard form. We have the exponents go from high to low. But that would be g minus f of x. Now, when I'm looking at the domain, what's the only thing that causes concern? Can't let x be 0, because then you're dividing by 0, which is not okay. So I'm just going to put a little note up here where it says determine the domain. X cannot be 0. Everything else is just fine. All right, keep on rolling here. We're going to see some more domain stuff. Ooh, this one. Alright, so GTIers, if you're on your way out, the homework's there in the back behind Ruth. And we're not going to finish 1-4, but get started on it and come back with questions. They're actually on Friday. Let me just say this real quick. Friday, we still have class, right? It's just going to be an online class. So there will be a video you watch, there will be a lesson you do, and there will be an assignment, but it's all going to be online, okay? So make sure you do that. Thanks, guys. Okay, so now we're on to this next one here. We still have the same f of x, the same g of x, but what are we doing for combining our functions? How are we combining them? We're dividing, that's what this means, right? So we're going to take g of x, which g of x is 3 minus 1 over x. And we're dividing it by what? 6x squared minus 2x. Now, I'm going to tell you guys, keep life easy for yourself. I'm just going to leave it like that. I've divided it. We're good. But what's the one thing we need to still figure out? The domain. Now, here's the thing. We can't let the denominator be 0, but how many denominators are there? Ladies behind Ruth on the chair. There you go. There's 2 denominators. I see this one right here. This one's easy. We're just going to put a little note here. Don't let that be 0. This one right here. Don't let that be 0. Well, this is easy. What's our first part of our domain? We can't let x be 0. This one takes a little bit more work. What would turn 6x squared minus 2x into 0? We can't let that be 0. Well, we're going to try to solve for x. But the problem is there's 2 of them. So does anyone know a good first step here? Factor out an x. Well, actually, we can factor out 2x, right? That leaves behind 3x minus 1. Now this is where I'm going to split it up and say, alright, so we can't let 2x be 0, and then we can't let 3x minus 1. That can't be 0 either. Okay, Ruth, I'm going to have you help me on this one. If I were to solve this for x, how would I do that? And then what would it give me?
You get x on one side, so you divide by 2.
Uh-huh. So 0 divided by 2 is 0. We already had that point from before, but okay, so we still know x can't be 0. Okay, and then now do that one, Ruth. Okay. Alright, so So this is going to add a point that x cannot equal 1/3. So I'm going to add that to my domain here. My domain is all real numbers, except x can't be 0 and 1/3. Alright, I'm going to introduce this next topic. It's a new thing, you haven't seen it before, and it's something you'll definitely see when you go into calculus. So I'm going to try to explain it as simple as I can. Before I do you have any questions on anything we've done up to this point? Okay, let's talk about slope. Alright, do you remember with lines, we have slopes here. What is another word for slope? It's rate of change. Do any of you remember how we calculated slope? What was that? Sometimes we say slope is, there you go, it's rise over run, which it's a change in y over the change in x. So slope is, and I'm going to put this little triangle here, the change in y over your change in x. Well, to figure that out, you would say, well, let's take our 2 points. Let's say I have a point right here. I'm going to come back a little bit. Let's say this is x1, y1. And here's another point, x2, y2. And we're going to say, what's the slope? What's the difference? Well, to get the change in y, you do y2 minus y1. To get the change in x, you do x2 minus x1. You remember that, right? Can you find the average rate of change for things other than lines? Could you find it for a curve? We haven't done that yet, but can we? We're going to use the same formula here, okay? And it looks a little scary, but let me just explain that, and then I think we'll be okay, all right? So what we're going to do is we are going to look at a point on this. Let me kind of zoom down just a little bit so you can see this. You got it on your notes too, right? So what I'm going to do is, let's say I've got this curve right here. I've got this parabola. I'm going to look at this point x and say, okay, when I'm at x, when I plug in x, this is the y value. So here's my x, here's my y. We call it f of x, right? Now, instead of plugging in a whole nother point, let's just go over a distance here. We call it h. It's just some distance away from x. So I'm going to go x plus h. So I went x plus h. Now I'm over here. And then if I come up to here, this is a point, f of x plus h. Are you with me okay? So what I've got right here is I've got 2 points. I've got x and f of x. Then I've got x plus h and f of x plus h. Well, let's just use our same formula and plug that in. We're going to look at, to get your rate of change, the change in y over the change in x. In other words, we're going to do y2 minus y1 over x2 minus x1. So we're going to say, okay, let's take this height and subtract that height. When I do that, I get f of x plus h. That's this height. Then I'm going to subtract the other height minus f of x. And then we're going to divide it by the change in your x values. Here's my first one. I have x plus h. And then we're going to subtract the first point, which was x. This is your formula for rate of change for a curve. Now what you need to do is just simplify real quick. Nothing I can do up top, but what can we do in the denominator? The x's go away. So we get f of x plus h minus f of x over what is left over? H. Okay, this is your formula for calculating rate of change on curves. Now, you don't really need to understand how we derived it. I think it's helpful if you do. But if I had just showed you this and say, hey, this is your difference quotient, maybe you would have been like, where did that